Math B, we are on 6.2D lesson, creating cubic roots. And we are starting off with question 1, find the volume of the cube. So we have just what looks like a Rubik's Cube here. And if we're going to count the units of the width, this would be 3. The length would also be 3. And our height here would also be 3. So to find the volume of a cube, we just take the width times the length and times the height, or 3 times 3 times 3. We can also write this as 3 cubed, which is 27 units cubed. So if this is called a perfect cube right here because all the dimensions are equal. So if we're going to complete the table below for given perfect cubes, if our side length was not 3, but instead it was 2, our dimensions would just be 2 by 2 by 2. And the volume of cube in exponential notation would be 2 cubed. And 2 times 2 times 2 is just 8 units cubed, or 8 cubic units. If our dimensions were 5 by 5 by 5, our side length would be 5. And this would be 5 cubed. 5 times 5 times 5 is 125 units cubed. If our volume of a cube in exponential notation was 8 cubed, our dimensions would be 8 by 8 by 8, and our side length would be 8. Whereas if we multiplied 8 by 8 by 8, we would get 512 units cubed. If our side length was just s, this could be s, this could be x, it could be any variable. This would just be the side times the side times the side, or side length cubed. And again, the volume of the cube would just be side length cubed. So number 3, if given the side length of a cube is x, what formula represents its volume v? So similar to what we just did, instead of s, it's x times x times x. So if I have a cube here, it's x times x times x, or right here, volume equals x cubed. If the volume of the cube is v, what is the value of its side length? So if we're given the volume, and we're trying to find the side length, we can write the cube root of the volume is the side length. So cube and cube root are inverse or opposite operations. So we're doing the exact opposite thing. And the next part is going to have us list the first 12 perfect cubes. And if you are in my class, you have seen these hanging up above my whiteboard. These are the first 10 perfect cubes. So if I'm going to do perfect cube 1, this is just 1 cubed, which is 1 times 1 times 1, or 1. 2 cubed is 2 times 2 times 2, or 8. 3 cubed is 3 times 3 times 3, 27. 4 cubed is 4 times 4 times 4, 64. 5 cubed is 125. And then it goes up here, so 6 cubed, 6 times 6 times 6 would be 216. 7 cubed would be 7 times 7 times 7, 343. I'm going to stop doing arrows now. So 8 cubed, or 8 times 8 would be 512. 9 cubed would be 729. 10 cubed would be 1,000. 11 cubed, I know it doesn't say in the picture, but this would be 1,331, and 12 cubed would be 1,728. So this is going to be important for future problems because it's going to allow you to estimate a side length. If you have something where the volume is between 1,000 and 100 and, I'm sorry, if the volume is between 1,000 and 1,331, you know the side length would be between 10 and 11. So I gave you that example because this volume is between 1,000 and 1,331. So we know that we can estimate the side length should be, this side length should be between 10 and 11. So we're going to create a factor tree for 1,029. So if I'm going to take the volume equals 1,029, so I'm going to take the cube root of both sides to find the side length. So I know that if I were to divide 1,029 by 3, I'm going to get 343. If I were to divide 343 by 7, I'm going to get 49. We know that 49 is just 7 times 7. So if you will notice, I have 3 7s and then I just have 1 3. So I'm going to rewrite this as cube root of 1,029 is 7 cubed times 3. If I have 7 cubed, that means that I have 3 7s under that cube root, and I can take out one of them. I only have 1 3 though, so that stays under there. If I were to plug in 7 times the cube root of 3 into my calculator, it would give me a number that is between 10 and 11. So next question. So assume all variables represent positive numbers. If I am going to take the cube root of 125, if we're going to go back, we actually already did that. The cube root of 125 should mean that the side length of a cube with the volume of 125, the side length should be 5. Another way that I could do that is to create a factor tree. I know 125 divided by 5 is 25. 25 divided by 5 is just 5 and 5. So now I have 3 5s under there. So this, my answer here is just going to be 5. The cube root of 343, again, if we were to go back to our perfect squares, we already have that here. You're going to end up memorizing some of these the more we do them. But again, if we didn't know that and we created a factor tree, and I tried to find a number that 343 divided evenly, so 7 goes in evenly to 343, 49 times, and then we can break up 49 to 7 times 7. So I have 3 7s here, so that, and nothing left. So my answer here is just 7. For something that is a fraction under a cube root, I can actually break this up. So I can take the cube root of 1 over the cube root of 216. And the cube root of 1 is just 1 times 1 times 1. Cube root of 216, also a perfect square. That will be 6. So our answer here is just 1/6. I'm going to jump down to number 9. So again, I can break up this fraction, the cube root of 8 over the cube root of 125. Now, we have 2 perfect squares here again. If we're going to go back to our cube roots here, we have 8. The cube root of 8 will be 2. And then my other, what was my other one? 125. We know the cube root of 125 will be 5. So 2/5 will be my answer. Okay, 11, cube root of 108. So I'm going to try and think what number goes into 108 evenly. And I know that 4 goes into 108. So if I divide 108 by 4, I'll get 27. And I know that 27 can be divided by 3 to get 9. And 9 can be divided by 3 to get 3. Now I have 3 3's, but I still have this 4 here. So the cube root of 108 can be rewritten as cube root of 3 cubed times 4. And if I have something that is under my cube root being multiplied by itself 3 times, I can take it out of my cube root. So 3 can go out of my cube root. My 4 will stay under my cube root. Now we're going to deal with variables. So I'm first going to focus on the number and just think about what number actually goes into 128. And again, I know that 4 goes into 128, and that goes in 32 times. If I divide 32 by 4, I will get 8, and I can divide 8 by 4 and get 2. So I see I have 3 4's, and then I just have 1 2 here. So if I have 3 of something under the cube root, that can go on the outside of the cube root. What will go on the inside is still that 2. And I have 6 x's. So I could actually break my x to the 6 up into x cubed times x cubed. And if I have 3 x's, I can take 1 x out. But I have another 3 x's. So I take another x out, and it becomes x squared. So this answer will be 4x squared cube root of 2. 13. So 343, I'm just going to try and think what number divides evenly into 343. 4 doesn't go in evenly, 5 doesn't go in evenly, 6 doesn't go in evenly, but 7 goes in evenly. 7 goes in 49 times, and 49 can again be broken up into 7 and 7. So I know that the cube root of 343 is 7. So I can right away take 7 on the outside of my cube root. Right here, I only have 2 a's. So if I only have 2 of something and it's in a cube root, I cannot take it out of the cube root. So I'm still going to leave my a squared under there, and then I just have the b to the 8th. I'm going to rewrite that as b cubed times b cubed times b squared, because I have 3 b's here, 3 b's here, and 2 b's here. So I would have 8 b's. I rewrote it like that because now I can see that I have 3 here, so I can take 1 out, and 3 here, so I can take 1 out. So this will be 7 times b, or b squared. Those will go away. Cube root of a squared, b squared. Number 15, a little bit hard to see, but it says, does the cube root of -8 equal -2? Explain. So basically it's asking, can we have a cube root of a negative number? And a cube root is an odd number, so this is saying that we can actually have a cube root of a negative number, and it would actually be equal to -2, because -2 times -2 times -2 would equal -8. So yes, if I were to take the cube root of -8, that would equal -2. So now it's going to ask us for some more simplifying of negative numbers. So if I'm going to take the cube root of -1, this is just going to be -1, because -1 times -1 times -1, this will be +1 times -1. It will still equal -1. 17 cube root of -64 will be 4. So if I didn't know what number goes into 64, I could just break it up into 4. 64 divided by 4 is 16. 16 can be broken up into 4 and 4. So I have 3 4s under here. But because it's a cube root, it's -4 times -4 times -4. So my answer here will just be -4. Okay, next page will be number 18. Actually, this is a square root. It's trying to kind of go back to square roots here. So it's asking basically, can I have a square root of a negative number? And we don't have our little 3 here. This is the square root is the only root where you don't see a number here. So there would be no solution here. You cannot multiply a number times itself and get a negative number. I am going to go down to number 20 here. So if I'm going to take the cube root of 432, I know that 432 can be divided by 4, and that will get me 108. If I divide 108 by 4, I'll get 27. And I know the cube root of 27 is 3, so I could already take that out, or I could break it down further into 3 and 9. 9 divides into 3 and 3. So I have 3 3s here, but my 4s aren't broken down yet. I can break 4 into 2 and 2, and this 4 down into 2 and 2. Now I have 3 2s here and just 1 2 left here. So I'm going to write this over here and just cross out number 19. So I'm going to write the cube root of 432 is also 2 cubed times 3 cubed. I'm getting 2 cubed here, 3 cubed here, times 2. That means that I can take out a 2, I can take out a 3, and I still have to leave that 1 2 under there. So if I multiply 2 times 3, this is just going to be 6 cube root of 2. And then finally, 216. So this is going to be a negative number because inside is negative, and that's okay because it's a cube root and not a square root. So I can have a negative times a negative that will equal a positive, but I can multiply it times a negative one more time, and it will give me a negative number. So what goes into 216? I know 2 goes into 216. I know 6 goes into 216. 6 goes into 216 36 times. And I know 36 can be broken up into 6 and 6. So now I have 3 6s under here, but my answer will be negative. And that's all for 6.2D. So go ahead and join office hours or email your teacher with any questions.